All right, geometry video 2 here. All right, so let's move on. Okay, so this is another perpendicular bisector theorem problem, but more algebra-y, right? So it says, what is the value of AD? Okay, so if you look at this picture here, AC is perpendicular to BD, and since it's 11 and 11 on BC and DC, it also bisects DC. So AC is a perpendicular bisector. So segment AC is the perpendicular bisector of segment BD, right? That means that any point on AC is equidistant to BD, which means that A to B is the same as A to D. So A to B equals A to D. I have an expression for AB, 6x minus 10. I have an expression for AD, 3x plus 2. There's your equation. Use your algebra skills and solve. I'm going to move this 3x to the left by subtracting it. So if I subtract 3x, 6x minus 3x is 3x. So 3x minus 10 equals 2. Now I'm going to move this 10 to the right by adding 10. 3x equals 12. And then this 3 is multiplying with the x, so I'll divide. X equals 4. So your x value is 4. Now this is not the question. The question is, what is AD? Right? So we know that AD over here equals 3x plus 2. Take this value of 4 and put it in place of x. So that would be 3 times 4 plus 8. Use Desmos or your brain. 3 times 4 is 12. 12 plus 2 is 14. And there's the value of AD. So AD would be 14, and so would AB. And then just thinking ahead, right? If I wanted to find the length of AC, I can now use the Pythagorean theorem because I have a couple right triangles. So just see how this can progress. Cool. All right, so that's it for the perpendicular bisector theorem. All right, so now let's talk about the angle bisector theorem. So it says find equidistant points from the sides of an angle. So an airport baggage inspector needs to stand equidistant from the two conveyor belts. Equidistant from the belts. How can the inspector determine where to stand? So it's not like he has to stand equidistant from the ends of the belts. If he was the ends of the belts, it'd be points. But equidistant from the belts themselves, since the belts are acting like segments, we need to do this with an angle bisector. So what we're going to do here is we're going to find the angle bisector between the two belts. Right? So here's belt 1, here's belt 2. So this is the angle right there. And right there. So if you remember from Desmos, right, you would take this, you would make an arc across like so. So these 2 points are equal, and then you would take it and make an arc here and an arc here. So that these two distances were the same, and that would be, let me do this in a different color. Let's do it in green. So then where they intersect is there, and then that would be the angle bisector, right? So this would be congruent to this. And again, it is because the distance from here to the conveyor belt. And what we're going to do here is we're going to use a perpendicular distance. That distance right there should be the same as that distance. Those two distances should be the same. Okay? And again, it's the way that we constructed our angle bisector. So where should he stand, right? He should stand anywhere on this angle bisector. So he could stand there. He could stand back here if he wanted to, right? Perpendicular distance, perpendicular distance. Again, my line's a bit off, but those should be the same. He could stand back here if he wanted to. Perpendicular distance, perpendicular distance. So anywhere along this angle bisector, he could stand, right? So we should say the inspector should stand on what appears to be the angle bisector. So on the angle bisector between the two belts. There you go. So this one I feel is used less because typically we're about a point rather than like a segment or a side, but it has its applications. Okay, so let's talk about the theorems themselves. So here comes the conditional first. So it's called the angle bisector theorem. Again, big surprise. So if a point on the bisector of an angle, then it is equidistant from the sides of the angle. So a point on the angle bisector is equidistant from the sides of the angle, right? From the sides. So you can see here, AD is the angle bisector because these two angles are marked congruent. So the distance from B to D is the same as the distance from C to D. And again, notice it's a perpendicular because by definition, the shortest distance between a point, or the distance between a point and a line or a segment, is the perpendicular distance. Okay, the converse here. So now it says if a point is equidistant from two sides of an angle, then it's on the angle bisector. So if a point is equidistant from the sides of an angle, then it's on the angle bisector. So if we know that D is equidistant from B to C, which is again the side AB, the side AC, then we know that these two angles must be congruent, BAD and CAD, which means that segment AD is an angle bisector. Okay, so let's do one algebra problem and then we're done with this one. So what is the value of KL, right? So in this picture here, because of the congruent markings right here, we know that ray, JL, is the angle bisector, of angle KJM. And because we know that, right, we know that L to K is equal to L to M. These two lengths are equal. L to K is 2x plus 3. L to M is 4x minus 11. And we solve for x. I'm going to bring the 2x to the right by subtracting it. 3 comes down. 4 minus 2 is 2x minus 11. I'm going to add 11 to both sides to get the 2x by itself. 3 plus 11 is 14 equals 2x. And then the 2 is multiplying with the x, so we'll divide by 2. And I get an x value of 7. Typically in geometry, we don't stop there, right? We want to know what KL is. So KL's expression is 2x plus 3. Take this value of x and plug it in right there. 2 times 7 plus 3. Use your brain or a calculator. 2 times 7 is 14, plus 3 is 17. And we're done. Alright, so thanks for watching these videos, and we'll see you in class.